Welcome in, everyone. In this video, we are going to review writing equations for lines that go through 2 points, or writing linear equations. The first thing I want to talk about before we get into actually creating the equation for the line through these 2 points is the 3 forms of linear equations we use in math. So the first form is called our slope-intercept form, which is y is equal to mx plus b, where m is the value for our slope of our line. Remember, that's the rise over run, or change in y over change in x. And then that b is the value for our y-intercept. And a lot of times it's written as 0b to give us the point that our line intersects our y-axis. The next form is called point slope. It looks like y minus y1 is equal to m times x minus x1, where again m is going to be our slope. And the values for x1 and y1, x1, y1, is going to be a point on our line. So the 2 specifics, both of these deal with slope and both of them deal with the point on the line. When we talk about slope-intercept, the point that's on that line is specifically our y-intercept. When we look at point-slope, we still have our slope, but the point can be any point on the line that we can plug in to make our equation. And then the last form we will talk about is going to be standard form. Ax plus by is equal to c. And this more or less gives us our x and y-intercept, where our x-intercept is going to be c over a, 0. And our y-intercept is going to be 0, c over b. Sorry about that. Where we divide c by whatever's in front of the y, divide c by whatever's in front of the x for those corresponding x and y-intercepts. Okay, now, a common occurrence with 2 of the 3 of these is our slope. So a lot of times we need to find our slope in order to write the equation of a line through 2 points. And the way we're going to do that is we are going to calculate the change in our y values and the change in our x values, or the difference of our y's and difference of our x's. A lot of times you will see this written as y1 minus y2 over x1 minus x2. Sometimes it may be flipped. It doesn't really matter. The thing that matters the most when we're finding our slope is that this x1 and y1 come from the same point, and this x2 and y2 come from the same point as well. We can't flip the order of them. The order has to stay the same for us to find the true slope of the line. Okay, everything else will work itself out with signs. We're really just looking for how our y changes from point to point over how our x changes from that same corresponding point to corresponding point. Okay, so as we look to find the equation for the line that goes through points 3, -4, and 1, 4 in slope-intercept form, the first thing we're going to do is find our slope. And if it helps, go ahead and label your x1 and y1 for these, and then x2 and y2 for these 2 points. So you have that to refer back to. Okay, so I'm going to, since this is the first point listed, I'm going to list this as x1 and y1, and this is the second point, so this is going to be x2 and y2. So my slope is going to be equal to -4 minus 4 over 3 minus 1. Okay, you notice I put this negative in parentheses just to help me keep my values straight. So when I take -4 minus 4, I get -8. 3 minus 1 gives us 2. And I'm going to simplify that fraction to just make it into -4. Now, one way, because we were asked to write this in slope-intercept form, is I can plug in my m for my slope-intercept and then pick one of my points to plug in for my x and y and solve for my b. The method I prefer to use is I'm going to use my point-slope form. I'm still going to plug in this -4 for m, and then I'm going to take one of my points, either my first one or my second one, and plug in those x and y values into x1 and y1. And since I've already labeled this x1 and y1 over here, let's just use those 2 points that I'm going to plug in for x1 and y1 in my point slope form. So we're going to write this as y minus -4 is equal to, our slope is -4 times x minus, our x1 is going to be 3. So there we go. And the reason I like this is because once we have plugged everything in, all that's really left to do is to distribute and then isolate our y. So I'm going to distribute and then clean this up over here as well, because I have y minus a negative. It's going to become y plus 4. And I'm going to distribute the slope to the x and to this minus 3. So we have -4x plus 12. And then the last step we have to do to write it in slope-intercept form, because I need y is equal to something times x plus or minus a constant. So in order to get this y by itself, I've got to subtract 4 on both sides. And so that's going to give us y is equal to -4x plus 8. And that would be the equation for our line. And one thing we can do to check to make sure we did everything correctly is to look at our other point, and we have 1 as our x and 4 as our y. We can go ahead and plug that 4 in for the y here and 1 in for the x here to make it 4 is equal to -4 times 1 plus 8. 4 is equal to -4 times 1 is going to be -4 plus 8 would be 4. So everything checks out. So that's how we know that we have found the correct equation for the line through those 2 points. So let's look at another problem. We have the equation through the line that goes through points -2, 5 and -5, 0 in slope-intercept form. So again, I'm going to start off by finding my slope. And again, I can label this x1, y1, x2, y2. So I'm going to have 5 minus 0, 5 minus 0 over -2 minus -5. So I simplify 5 minus 0, well, that's going to give us 5. -2 minus -5, well, that's going to give us +3. So our slope is 5 over 3. So that means as our y changes by 5 up, our x changes by 3 to the right. Increase of 5, increase of 3 for our x and our y. So now I'm going to use this, and I'm going to plug it into either of, I'm going to plug it into slope-intercept or point slope using either of these points. So I'm going to take y minus, let's go ahead and use this first point, minus 5 is equal to 5 over 3 times x. And then because this is -2, okay, I could think of it as negative or minus -2, which I would clean up to be x plus 2. Okay, and then from there, I'm just going to distribute and then isolate my y. So I'm going to distribute this 5 over 3 to the x and to the +2. So we have y minus 5 is equal to 5 over 3x plus 10 over 3. Okay, because I take 5 times 2 would be 10 over the 3 in my fraction. And then I'm going to add 5 to both sides. So we have y is equal to 5 over 3x. And because I'm adding 5 to this value, remember we have to get common denominators. So I can rewrite this 5 as plus 15 over 3. Okay, again, I gotta have common denominators in order to combine a fraction with a whole number. So I'm gonna think of it as plus 15 over 3, which would give us 25 over 3. And there's our equation. So sometimes it can work out nicely to where we have equations that look like y equals negative 4x plus 8, where everything's a whole number or an integer. Other times it may end up to where we have a fraction for our slope or even for our constant. Okay, so next thing we're going to look at is we look at the equation of lines parallel and perpendicular to given lines that go through a point. So we're going to write the equation of the line in slope-intercept form that is parallel to y is equal to 1 over 3x minus 2 and goes through the point negative 4, 1. So really, when we're creating lines, we need a slope and we need a point. Well, we're given a point for our line, and we're also given that it needs to be parallel to this line. So our rule with parallel lines is they have the same slope. So I know the equation of the line through this point has to have the same slope as this line because it has to be parallel to this. Well, if we go back and look at our different forms, we see that this equation is written in slope-intercept form, y equals mx plus b, and in place of the m for this equation is 1 over 3. So, because we know that our line has to be parallel to this one, if the slope of this line is 1/3, the slope of our new line has to be 1/3 as well. And then we're going through the point negative 4, 1. So I go to put this in point slope form. This is going to be my x1, and this is going to be my y1. So I'm going to write this as y minus 1 is equal to 1 over 3 x minus negative 4. We're going to clean this up a little bit. Y minus 1 is equal to 1 over 3 x plus 4. I'm going to distribute the 1/3 out. So we have y minus 1 is equal to 1 over 3x plus 4 over 3. We're going to add 1 to both sides. But because we're adding that 1 to a fraction, we have to think of it as 3 over 3, because we have to get those common denominators. So we're going to have y is equal to 1 over 3x plus 7 over 3. And so that would be the equation for our line that is parallel to this one and goes through this point. Okay? Our last example, we're going to talk about perpendicular. So we're going to write the equation of a line in slope-intercept form that is perpendicular to what we have here and goes to the point 3, 1. So with perpendicular lines, the slopes are going to be opposite and reciprocals, meaning we change the sign and flip the fraction. Okay, so again, perpendicular to this one, we're going to look at the slope. The slope of this line is 5 over 2. So the slope for our new line, if we change the sign on this and flip it, it becomes negative 2 over 5. And we're going to go through the point 3, 1. We have an x1 and a y1, not a y2, a y1. So again, the big rule with perpendicular, with our slopes, if we're writing a line perpendicular to this one, we have to look at the slope, change the sign, and flip the fraction. And we'd have to take the opposite reciprocal. So I'm going to plug everything in. Y minus 1 is equal to negative 2 over 5 times x minus 3. Don't have anything to clean up, so I'm going to go ahead and distribute the slope to both things in parentheses. Negative 2 over 5x plus 6 over 5. And then we're going to add 1 to both sides, which our 1 has to look like 5 over 5 so that we have common denominators. So there's the equation for our line right there. So that does it for this video, writing equations or linear equations for lines either through 2 points or parallel and perpendicular to a line through another point. I'll see you all in the next one. Bye.